Okay, so hello everyone, my name is Aryan. I'm 11 years old. So my father's name is Naveen Kumar. So today I'm going to present something on string theory, what it is, and how it was discovered. What are the main things, key roles in this theory? So yes, we are going to start with the presentation. Introduction to string theory. So, string theory is a theoretical framework in physics that attempts to recognize general relativity and quantum mechanics. It proposes that fundamental particles are not points, but rather one dimensional strings. These strings vibrate at specific frequencies, determine the property of the particles they represent. So, like this is an attempt to what you can call fuse both quantum mechanics and general relativity together. So yes, wait a minute. Yes. So it suggests that there is one thing called a string that vibrates and produces that type of energy. So yes, this is the key frame of what can call string theory. So yes, so these strings are fundamental objects, very small in length, around 10 raised to the power of minus 35 meters, and are vibrating at different frequencies that create different types of particles. So, and they also and vibrational modes. So, different types of frequencies corresponds to various particles like electrons and photons. And super strings. There are two types of strings: open string with free ends and closed strings loops. So yes, and dimensions. So there are, it suggests that there are 10 dimensions, including our familiar three dimensions of space and one dimension of time plus six additional dimensions. So this theory predicts that there are other dimensions also, but we do not know what, how would be there, would we get some extraordinary powers, etc. So yes, it does not predict that, but it predicts that there are other dimensions also. And some key concepts like quantum gravity, it's unifying general relativity and quantum mechanics. So it is an attempt to fuse quantum mechanics and general relativity together. So, the string landscape, multiverse hypothesis predicting diverse universes. So yes, unification explaining fundamental forces, gravity, electromagnetism, strong and weak nuclear forces. So yes, there are types of string theories. Bosonic string theory. So it is the initial version including bosons. And the superstring theory in 1980. So it predicts fermions, matter particles, and the M theory. So we will discuss it later. So I think so we should move to the next topic. Many new people have also joined. Historical background of string theory. So, string theory emerged in the late 1960s as a candidate for an unified theory of fundamental forces. The initial development was motivated by the needs to explain hadronic particles interactions. So, over time, it evolved to encompass gravity and aims to be a theory of everything. So, this it is an attempt to understand every fundamental force there is. So yes, some key researchers were Edwin Witten, etc. So yes, some modern developments are uh, the string physiology, exploring particles, physics, and implications. So it suggests that there are thousands of millions of universes, and we have to find one of ours also. So yes, moving to the next topic. Fundamental concepts of theory. So yes, strings can exist in different vibrational modes, each corresponding to different particles. The theory requires additional dimensions beyond the familiar three of space and one of time. So these extra dimensions help in explaining the fundamental forces of nature. So yes, so some concepts of these are the strings, dimensions, superstrings, D brains, higher dimensional objects interacting with strings, and string properties are like vibrational modes, tension, length, orientation, etc. So yes, some theoretical framework would be the string theory action, mathematical framework describing string dynamics. So yes, so it aims to what you can call unify everything that there is, uh, fundamental forces like the gravity, electromagnetism, strong and weak nuclear force. So it is also called the theory of everything. But some physicists uh, do not accept that and suggest that there would be more of more. So yes, I think so. Okay. So yes. So types of strings. So there are two types of strings, open strings and closed strings. So these open strings have two endpoints, while closed strings form loops without endpoints. The behavior of these strings is essential for understanding various physical phenomena. So yes, the first one is the open strings, free ends, and can interact with d branes, and some examples are quarks, leptons, and bosons. So the second one, the closed strings. So these are loop-like structures. They have no free ends. Examples: gravitons and dileptons. So yes, some more types of strings are there. The fundamental strings. So these are the shortest possible length, Planck length. So these vibrations corresponds to fundamental particles. Examples are of the electrons, photons, and quarks. So these open, and the fourth one, these strings are also there. Open strings are attached to D branes. So these are interacted with other D brain strings and closed strings. So these play a role in D brain dynamics. So yes, there are many types of strings, around 10 of them. And there are some more there are other types of strings also. The cosmic string, the domain involves fundamental strings. So yes, these are mostly the types of strings there are in the string theory. So, ladies and gentlemen, any questions for me? Okay, I don't think so. So, yes, dimensions in physics according to string theory. So, in physics, Dimensions refers to the different aspects in which physical entities exist. So these are the traditional view includes three spatial dimensions and one time dimension. However, advanced theory suggests the existence of additional spatial dimensions. So, like what happens that a dimension is a place where an physical entity lives. So, if there is an ant on the paper, and then we see that there is only limited space there, but the ant would think that it's infinite, and when we would pick it up, it will see that it was just an illusion. So, we could be the ants on the paper. So, yes, so dimensions in string theory suggest that there can be 10 dimensions, 3 dimensions of space, a length, width, height, and 1 dimension of time. 6 additional dimensions. So yes, so physics implications, string theory, extra dimension leads to unification, new particles, extra dimensions. So yes, string theory view of physics. So strings has fundamental objects replacing point-like particles. So vibrational modes corresponding to different types of particles. And people also suggest that the upper types of dimensions can interact with our universe. So yes, and some concepts of this are the supergravity, supersymmetry, etc. And so I think some new people have also joined. So yes, if you have any questions, try to ask us.
Then
So,
little bit kindly a little bit brief your presentation. You have
so
left some slide also, so some person is also joined. Ma'am is also joined.
okay. So right now we are talking about string theory and what it predicts and what its key plays are, like the strings, superstrings, etc. So yes, we are now on the topic of dimensions in physics. So yes, string theory suggests that there are extra dimensions, one of time, three dimensions of space, length, width, and height, and the sixth additional dimension. And some physicists also say that our atoms are very big to enter these dimensions. So yes, these dimensions can be very small. So yeah, most of these things are related to the string theory and also called the theory of everything. So yes, some theoretical framework, the type 1 string theory and the type 2 string theory and heterotic string theory. So these are just different frameworks of string theory. So ladies and gentlemen, any questions for me? So I don't think so. We should move to the next topic. Okay. The concepts of extra dimensions. So extra dimensions are necessary for string theory to be mathematically consistent. So these dimensions are often compactified, meaning they are curled up and not directly observable. Understanding these dimensions is crucial for the unification of physical laws. So yes, as I said, that these extra dimensions could be very small and our atoms are just very big to enter those. So yes, so types of extra dimensions. So large extra dimensions. So these are proposed to be large enough to be detected, and warped extra dimensions with varying size and shape. So And the last one, compactified dimensions. So these are so curled up and are very difficult to be observed. So string theory requires 10 dimensions, of which 6 are compactified. And Kaluza-Klein theory, so it proposes extra dimensions to unify gravity and electromagnetism. And the brain theory, so it involves extra dimensions and d brains. So yes, so some properties of extra dimensions can be, I think, a size. So these can be very compactified around the Planck length, which is around 10 raised to the power of minus 35 meters. And topology is the study of properties preserved under continuous deformations. And shapes, so these can be a toy shaped or anything. So some implications of extra dimensions can be unification. Extra dimensions facilitate unifications of fundamental forces. So some new particles can be discovered. And gravity. Extra dimensions affect gravity's behavior at small distances. So yes. So uh, ladies and gentlemen, any questions for me? Okay. So I think there are no questions. We are going to move to the next topic. So Kaluza-Klein theory. So this is an early attempt to unify gravity and electromagnetism using extra dimensions. It introduces a fifth dimension, that is compactified, to explain electromagnetism effect. So this theory lays the groundwork for later development in string theory. So Kaluza-Klein theory. It is a very early attempt to unify everything like gravity and electromagnetism. So this is just an theoretical framework that attempts to unify gravity and electromagnetism by introducing additional spatial dimensions beyond the three familiar dimensions: length, width, height, and one dimension of space. So yes, and some key components are: the extra dimensions can be compactified, the metric, a mathematical object describing the geometry of space-time, and Kaluza-Klein decomposition, separation of fields into components along the extra dimensions. So yes, it was a very early attempt uh, to understand gravity and electromagnetism. So yes, so but some limitations are like experimental evidence. So there is a lack of direct experimental confirmation and mathematical complexity also. So these introduces additional complexity and multiverse problems. So predicts diverse universes. So yes, these are the challenges of it. So what it predicts is that uh, extra dimension influences. So these can affect particles, interaction, and properties. So like the dark matter or dark energy can be just some other particles from new other dimensions. Yes, these can be. And so this was the Kaluza-Klein theory. Ladies and gentlemen, any questions for me? Okay, I don't think so. Types of extra dimensions by string theory. So these extra dimensions can be large, small, or compactified to various shapes like circles or tories. So these the geometry of these dimensions affect the properties of particles and forces in our observable universe. Different compactization methods lead to physical implications in string theory. I think some new people have also joined. So yes, okay. So where we were so on types of extra dimensions. So these can be large extra dimensions, warped extra dimensions, compactified dimensions, uh, curled up or not uh, directly observable. So yes, string theory extra dimensions, type 1 string theory, there can be 10 dimensions and 6 compactified. Type 2, 10 dimensions, 6 compactified. And yes, the M theory, 11 dimensions, 7 compactified. So yes, it suggests that our atoms are very big to enter these extra dimensions. So yes, and some properties of extra dimensions, size. So these can be around the Planck length, sh- shape and topology. So yes, we have already discussed this in our uh, previous slides. So yes, moving to our next topic. Ladies and gentlemen, any questions for me? Okay. So the next topic is about Calabi Hue manifolds. So these are specific shapes used in string theory to compactify extra dimensions. So these provide a way to preserve supersymmetry, a critical feature of many string theories. And these the topology of these manifolds influence the types of particles and interactions in the theory. So yes, moving to the next topic, it is about string theory models. So there are several models within string theory itself, including type 1, type 2A, type 2B, and heterotic string theory. So yes, so each model has its unique characteristics and implications for particle physics and cosmology. So these the diversity of models allow for different approaches to solving fundamental problems in physics. So yes, so there are many models in string theory. So type 1 string theory. So it suggests that there are 10 dimensions, 6 are compactified, and there are open and closed strings, and it predicts that there can be gravitons, electrons, and other particles. Yes. So, and the other one is type 2 string theory, 10 dimensions, 6 compactified, orientated strings, predicted supersymmetry, A and B subtypes. So, yes, I think so. Mritin Bhaiya has also joined. So, thank you for joining. If you have any questions, you can raise in hand and ask us. So, yes.
You can a little bit brief na about the string theories. Some person will join later.
Okay. So we are discussing about the string theory, what it suggests, and what its key principles are. So we have learned that in string theory, what happens that there are different types of strings. When they vibrate, they create a different type of frequency and uh, and also energy. So that creates new particles. So yes, We were on heterotic string theory. So it suggests 10 dimensions and 6 are compactified. So it has closed strings and combines benefit of type 1 and type 2. So yes, it also has two or three subtypes also. The M theory, 11 dimensions and 7 are compactified. So unified framework for string theory and predicts gravitational forces. So and the fifth one, the F theory. So it has 11 dimensions and 8 are compactified. The string theory landscape. So it suggests that there are multiple universes and predicts diverse physical laws, that each universe has its own rules, own type of gravity, etc. So yes, these are some models of the string theory and mostly predict that the string vibrates and produces energy. Moving to the next topic, ladies and gentlemen, any questions for me? Okay, no. So M. So yes, we are now moving to a topic, M theory. So this is just an extension of string theory that proposes an 11 dimension universe. So it unifies the five different strings theory into a single framework. So this M theory introduces membranes and higher dimensional objects alongside traditional strings also. So it is just an theoretical framework in physics that unifies all consistent string theories into a single one. And it suggests that there are 10 spatial dimensions and one time dimension. And membranes, so higher dimensional objects, M-branes replaces strings. So yes, unification M theory encompasses all string theories, type 1, type 2 and the heterotic. Supergravity includes supergravity theories, and yes, and some predictions are the gravitational forces. M theory predicts gravitational forces and new particles, so it predicts new particles and forces. Multiverse allows for the possibility of a multiverse, each with its own rules and regulations. So yes, so some advantages are unification. So it tries to unify all the fundamental forces there are. So yes, and many challenges are also faced to it, like the mathematical complexity. So it is a highly mathematical theory and the multiverse problem. So it predicts an infinite number of universes and the lack of experimental evidence. So yes, this is the M theory. So yes, it is just a combination of all the string theories that there are. Now we are moving to the next topic. So, ladies and gentlemen, any questions for me? Okay. So, yes, now we are going to move to a next topic, supersymmetry. So, it is a theoretical symmetry that relates bosons and fermions in nature. It is an essential feature in many strings theory, helping to solve various problems in particle physics. Although not yet experimentally confirmed, but this remains a strong area of research also. So this is also a theoretical concept in physics, proposing the existence of supersymmetric partners. Spark. So these are known for particles. So yes, Some key points: symmetry between boson, force carriers, and fermions, matter particles. So each particle has a supersymmetric partner with different spin. So yes, particles have identical properties but differ in spin by 1 by 2. So yes, some known particles and particles. So electrons, fermions, and bosons. So yes, as you can see in the picture given, there are different types of particles, uh, charm, etc. So yes, and some implications. So it can explain for dark matter and potential solution to hierarchy problems, unification of fundamental forces that we will discuss later in the presentation. So, ladies and gentlemen, any questions for me? Okay, I don't think so. Moving to the next topic. So the next topic is quantum gravity. So this theory aims to provide a quantum mechanical description of gravity. So unlike classical theory, it treats gravitational interactions as rising from string vibrations. So this approach has implication for our understanding of black hole and the early universe. So yes, so quantum gravity, it is it is an so this seeks to merge quantum mechanics and general relativity, describing gravity behavior at atomic and subatomic levels. Theories are the loop quantum gravity. It describes spacetime as discrete loops. String theory. String theory has fundamental objects. Yes, and quantum gravity effects. So it can alter wave propagations. Black hole entropy explains information paradox, and the quantum foam describes spacetime grainy structure. So yes, so we are what we call, it is also theoretical and not proven practically. So yes, moving to our next topic. So challenges and criticism against string theory. So yes, so this string theory faces several challenges, including difficulty in making testable predictions. Critics argue that the lack of experimental evidence undermines its validity, and ongoing researchers seeks to find way to connect string theory with observable physics. So what challenges and criticism is that we do not have uh, practical practical things to prove it, and most people say that it's just theoretical. And challenges are black hole information paradox, cosmological implications, mathematical consistency, and experimental verifications. So yes, so what it happens that it requires high level of mathematics, and there are multiverse problems and lack of experimental evidence. So yes, moving to our next topic, experimental searches for strings. So physicists are exploring high energy particle collisions to search for evidence of string theory. So it predicts the existence of extra dimensions that could be detected at particle accelerators. So the discovery of supersymmetric particles could also support string theory models. So yes, everybody knows what the large hadron collider. So searching for supersymmetry particles and extra dimensions happens here, and I think so. It also had discovered a new particle, the OMG particle. So yes, so many types of experiments are going on also. So experimental signatures, has string theory been proven? I think so. Someone has asked his question. So, like what happens that string theory and M theory remains theoretical frameworks and are lacking direct experimental evidence. So, like what happens in physics that it needs time to be proven practically. So, yes, right now it is just a theory, just a theoretical framework, and the answer would be no. It has not been proven right now practically. So, yes, thank you for asking the question, Sayed. Are you satisfied with the answer? Okay. Uh, okay. So yes. So yes, these are the current experiments going on. Okay. So Muhammad Sayyid Muhammad has written thanks for clarity. So yes, you are welcome. Moving to our next topic, implications for cosmology. So this string theory offers insights into the early universe, including the Big Bang and cosmic inflation. So it suggests that the multiple expansions and contractions. So the interplay between strings and the geometry of space-time could explain cosmological phenomena. So yes, so early universe cosmology, inflation. So the string theory provides mechanism for inflation, explaining the universe isotropy, reheating. So it predicts reheating the transformation from inflation to radiation dominant era. So yes, some cosmological signatures, the gravitational waves. So string theory predicts gravitational waves signatures testable by LIGO and Virgo. Some experiments and the cosmic microwave background. So yes, string theory predicts CMB constrainting models. So yes, and the large scale structure, string theory influences galaxy distributions and clustering. So string cosmology scenarios, the brain inflation. So inflation occurs between brains in higher dimensional space. So the string gas cosmology, so string dominates the early universe energy density. So yes, and the black hole cosmology, so black hole entropy. So string theory explains black hole entropy, resolving information paradox. So yes, and black hole formation, string theory predicts a black hole formation mechanism. So yes, these are the implications for cosmology by string theory. So yes, ladies and gentlemen, any question for me? Uh, Another question from Muhammad. So is the universe really infinite or just really big? So yes, I think someone has asked that question. Muhammad has asked. So yes, most people speculate that it is just expanding cause light has a finite speed. So yes, so the Big Bang theory suggests the universe began as a singularity expanding rapidly. So right now we do not have evidence that it is just infinite or yes, but we know that it's expanding because light has a finite speed. So yes, Moving to a topic, string theory and black holes. So string theory provides framework for understanding the nature of black holes. So it offers potential resolutions to the information paradox associated with black hole evaporation. So the microscopic description of black holes in string theory involves counting string states. So so string theory and black holes. So it gives a framework for understanding the nature of black holes. So it suggests gravitational waves. So black hole mergers produce gravitational waves and spring-like motion. So stars orbiting black holes exhibit spring-like motion due to gravitational potential. And black hole entropy, black hole surface area entropy increases with observed matter like a strain potential energy. So yes, and some black hole properties mass. So it is measured in solar masses, spin, measured by dimensional spin parameters. So yes, black hole types. So there are mainly three types: stellar mass black holes about 10 solar masses, supermassive around a billion, and intermediate black holes about 1,000 to 100,000. So yes, some researchers were Stephen Hawking. So Stephen Hawking also predicted that they lose mass by what can call Hawking radiation. So what happens? That two particles are when are created near the black hole's event horizon. So when other ones fall into the black hole, if the other particle pair escapes, so it would lose some mass and is very slow. So yes, this is the Hawking's radiation. So future directions in research, uh, string theory. So future research in string theory aims to connect it with observable phenomena in particle physics. So efforts continue to develop mathematical tools to understand the implications of extra dimensions. So work across theoretical and experimental physics is crucial for advancing the field. So theoretical research is going on like of black hole information paradox, quantum gravity, black hole entropy, and modified gravity theories. So some observational research, gravitational wave astronomy, black hole imaging, black hole merger, cosmological black holes, etc. is going on here. So yes, conclusion. So conclusion of string theory. So string theory represents a promising avenue for a unified theory of fundamental forces. So the exploration of extra dimension is central to its mathematical structure and physical implications. So continued research may eventually lead to breakouts in our understanding of the universe. So yes, we so some achievements are the unification of fundamental forces, the explanation of particle properties, potential solution to black hole information paradox. So yes, so thank you for joining us here. Hope that everybody liked the presentation. So yes, we are now the presentation is finished. I hope you like this.
Yes,
So
Aryan,
yes,
you are doing great job.
Thank you, ma'am.
Yes, Aryan, keep it up, okay?
Okay, ma'am.
So, yes. If anyone want to ask some question to Aryan and general science also, he is studying sixth grade. Right now, he is much interested about the astronomy. So, hello everyone. If you want to talk with Aryan, please speak.
Okay. Any questions for me? Mrityunjay Bhaiya, do you have any questions for me? Okay. Okay. So yes, any questions for me? Mrityunjay Bhaiya?
Hello, Aryan. Am I audible?
Yes.
Yeah,
Do you have any do
no,
you have
no.
any questions? So did you like the presentation?
Yeah, I liked it. But can you
Okay.
explain me all the terminologies that you have used in the presentation?
Okay. So a summary of that.
No,
Okay.
not the summary, not the summary. I have seen the presentation. Can you explain me all the terms that you have used in the presentation?
So yes.
Like, wait, let me see.
So in string theory, what is there that there are different types of strings.
Okay, so what is a string then?
That is there.
What is a string actually, as per you?
One. So the open one has two endpoints, and the closed one forms a loop.
Okay.
So yes, when they vibrate, they create energy, and that we call a particle. So yes, was that enough? I don't think.
That is there, but can you tell me like why did we need a string theory in the first place?
I did not get your question.
I'm asking that why did we need a string theory in the first place?
Okay, why do we need a string theory? Okay,
Yeah.
so I think in the old times, what happened that classical physics was most dominant, and what happened that it did one thing wrong about if a bulb is lit up, so it would radiate infinite radiation. So that is why we are searching for another theory of everything. And what happened that most of the people were convinced that classical physics was the theory of everything, but it did one thing wrong, and that's why we needed another theory of everything. So yes, I think so. This is the story.
So what is the main role of string theory here? Like what does it do?
So role of string theory. What it does do. So like I'm thinking. So it tries to unify all of the fundamental forces that there are, and so yes, and one more thing was there, and it also tries to answer that why is why is gravity so weak and etc. and tries to uh, get them in place by decreasing strength. First, I think so is of the strong nuclear force and electromagnetic force. third weak nuclear force, and the last one is the gravitational forces. So yes, it tries to unify all of these fundamental forces. Yes, any.
So has it been successful in doing that completely?
Okay, I will tell that right now no, cause it is just a theoretical framework and not proven by practical things. So yes, not proven practically, but most people think that it would succeed, but we cannot prove it practically right now. So it is just a theory, a theoretical framework.
Okay, so also you have mentioned your quantum gravity in your one of your slides. So can you tell me what is exactly quantum gravity?
So quantum gravity, so it is a mix of the general relativity and the quantum mechanics or the quantum physics, you can say. So it aims to merge these two into one thing. So yes,
And that
it
is the
tries to
aim. Like, what exactly it is?
what it exactly is. So it
Yes.
tries to explain gravity at subatomic levels and the particle levels also. So at gravity at small places.
So how do you think that works?
Okay, so I think so. It is also theoretical framework and not proven practically. So yes, we have a long way to go for the theory of everything.
Okay, great. And one more thing I mentioned is string theory and black holes. So how can you connect those two dots?
Okay, so string theory and black holes. So it tries to what you can call solve the information paradox by I think so calculating how much energy etc. or how much lifetime it can live. I think so. I also have a little idea about it. So yes, that's a little bit I know. So yes.
Okay. And so what about supersymmetry? So what is your view on that?
Supersymmetry. Okay. So it suggests that supersymmetry proposed that uh, existence of supersymmetric partners like one pair and the other one, up, down, etc. So yes, and for each known particle, differing by some spin, so like antimatter, antimatter and matter particles. So yes, like quarks, the supersymmetric is the up, down, charm, etc. So yes, so each particle has a supersymmetric partner, like the up and down. It is like the antimatter and matter particle pair. So yes.
So is there any uh, uh, like we have our universe? Is there any universe symmetrical to us, obeying the same laws of supersymmetry according to you?
So I will say that there can be a universe that can have mm, our rules, and I think so. It would turn out different than us. So yes, I think so. There can be because there it also proposes multiverse theory also.
Okay. So can you explain me the string theory models in your own words, like type one, type two A? What are those in your own words? Whatever understood.
So so type one and type two are what can call practically same, a little bit different, and the M theory suggests that there can be 11 dimensions and 7 compacted. So it suggests that our atoms are too big to enter into these higher dimensions. So yes, our atoms are just too big to enter these extra dimensions. They can be compactified, and also suggest that they can be extra large dimensions in the universe. So yes,
What is type 1 actually? Like, what does it define?
what is type 1 string theory? So it suggests 10 dimensions, 6 are compactified, and one and we are living in the three, the width, length, depth, and one of time. So it is just a variant of string theory that includes both open and closed strings. So okay, so and I think so it contains of open and closed ones. So supersymmetry and the time dimensions. So it, I think so. I also have a little idea about it, and so it suggests that other eh, higher dimensions can interact with us, and that can also explain some unknown mysteries of the dark matter, etc. So yes,
And what about type 2A and type 2B?
type two string theory. So it, I think so, proposes 10 dimensions. Six are compactified, and we are living in the length, width, and depth, and one of time. So yes, it is another variant of the string theory. So that also includes supersymmetry and requires 10 dimensions, and it is divided into two subtypes.
But you
So
told the
yes,
same for type 1, right?
uh, no, I don't think so.
I think so. You told the same thing for type 1.
No, it does. I think so.
Okay, then what is type 1?
So it is another variant of string theory and contains open and closed string theories, and it is a 10-dimensional theory with supersymmetry. Yes, and one more thing, there the higher dimensional objects where open string can and they can interact with ours universe. So I'm just started with the string theory and will try to understand it. Like I'm not also an expert in string theory. So yes.
Great, great. Go ahead.
So yes. Okay. So it's almost now time. It's 12:03 here. Okay.
Okay, sir. Thank you so much for everyone joining us. And next Sunday will be join on 11 o'clock on time. And
Yeah.
thank you so much for giving your precious time to join this webinar. And Aryan always try to improve his presentation and also say question and answer also. So, okay, Aryan, thank you so much for joining. And what is the
Okay.
next?
So I think so. It would be around uh general relativity, etc.
Achha, okay. And some person is new join also like the Salim ji and Muhammad. So can you a little bit introduce a little bit your side and Sadia ji also. So साधिया जी, which location you have joined?
Yes,
आप कहाँ से ज्वाइन किए हैं?
from HBR layout.
So you have enjoyed this session.
Yes.
So you have any question to Aryan about the science?
No.
No. Can you introduce a little bit your side? Your name, education, and others one.
Actually, my name is Muhammad Rayan. I am in Aryan's tuition
Okay, good, good. Yes.
and I study in Royal Concord International School.
Okay, great. And which location you have joined? You are joined from?
HBR layout, Bangalore.
Ma'am is also joined from the Bangalore. Okay, understand. Okay, thank you so much. You can join also on next Sunday. Okay, Aryan, take rest.
Yes.